Looking at the buoyancy air pump for the micro ROV. If you've followed the progress of the micro ROV build, you'll see that I use air to assist in altering the buoyancy during any flight of the micro ROV. I plan to use a 12 volt air pump topside with a length of tubing down from the pump to the ROV. I have control on the control panel to turn the pump on and then regulate how much power the motor and pump receive, allowing me to fine tune how big these buoyancy balloons on the ROV will actually become. And the amount of air within the pods on the ROV will control the depth at which the ROV will actually maintain. The ROV is neutrally buoyant on the edge of being heavy, in inverted commas, thus sinking very slowly to any lake bed. The slightest amount of air added to the buoyancy will halt the sinking of the ROV, or in fact bring it back ascending through the water to the surface of any lake. I've looked at a number of air pumps and this is the latest. It's 12 volt. It likes variable power. Some don't apparently, and like to be constant. I need something that can go from ticking over very slowly, move through a power range to full power when requested via a potentiometer, which, as you may or may not know, will control a motor with a variable output. Looking at the air pump, there are two ports. One is an outlet that provides air pumping, and this port will actually cause suction. There may be some uses for that in the future, but for now all I need is an outlet to supply via a long length of air pipe light and flexible down to the ROV. This mock-up is exactly the same pipe I'll be using, which is normally the type of pipe is normally used within home aquariums. So it's very cheap and seems to be just the job. There's actually a T-piece inserted in the end of it to allow me to use two devices to explain the process. The two devices shown here are latex balloons commonly used for water bombs. My thinking was they don't inflate to extremely large sizes, but they are robust enough or better than a conventional balloon for this purpose. Let's see what happens when we power up the air pump. It's just going on to a small 12-volt battery. The pump is quite efficient really, but what it seems to need is an absolute tight joint around the T-piece. Without the tight joint, as much air is pumped out as goes into the balloons. If we can get the balloon to inflate, we'll see a phenomenon where one balloon always inflates first until you constrict the balloon, and then the second balloon will inflate. And this leads us full circle to the reasoning of why the balloons are going to be constrained within the side pods of the ROV. This restraining means that whichever balloon inflates first will be constrained by the hole in the side pod, thus allowing the second balloon to inflate and provide adequate buoyancy to raise the ROV to the surface. So I'll power this up again, grip the balloon to the point that it inflates, and then constrain it so that the second balloon inflates. I guess you could say that test went with a bang.